So now in this video we're going to look at how circuits usually have alternating flashing LEDs. So one LED will be on or the other. And so this circuit, what we're going to do is I'm just going to take a jumper, but I'm going to simulate a toggle switch. Sometimes I might be to the positive side of the power supply, sometimes to the negative side of the power supply. And depending on which one I go to, one LED will be lit up or the other. So if we leave it floating though, you can see we have a direct path through these four components. We're going to use 5 volts. The green LED drops about 3 volts, but at lower currents it goes down a bit. And the red LED drops about 2 volts, but at low current it drops down a bit. So they drop a little less than 5 volts at low current. And we'll get a little current trickling through. We'll see the green LED light up, but probably not the red. So in any case, we're going to simulate a integrated circuit output. So what they do is they're either outputting as close to the positive supply as they can get. So they usually fall short. We're just going to use a wire jumper to make a direct connection. So that's why I wrote ideal. Ideally, the integrated circuit output would make a direct connection to one supply rail or the other, but it can't. It has transistors and stuff within it. But it gets as close as it can. So in any case, we get a high input. That means the supply voltage usually, and it's often 5 volts. And then the red LED is going to light up. So I like red for the high voltage there, positive supply. And then green LED, I usually use green or blue, but in any case we go to the negative supply right there, and you can see we have the 5 volt difference going that way. The green LED will light up. So now when we have the connection to the positive supply rail, there you can see that is also the positive supply rail. So we have a connection like this. And so that's why the green LED will not light up. Well, we're at 5 volts, but we got 5 volts, we'll go down to 0 volts. There's a 5 volt difference across these two components. 5 volts on one side and 5 volts on the other, there's no voltage difference. That's the main thing to be aware of. That's why one LED lights up. And then we go to ground. The red LED can't light up. We got 0 volts on both sides. That's the same voltage. But we do have 5 volts going along there. Now I have a higher value resistor, 1 kilo ohm, protecting the green LED because it's naturally brighter. We'll have 5 volts when it goes to ground. And then with the red LED, same thing. We'll have 5 volts when it's to the 5 volt supply, the positive supply right there. And then ground on the other side, there'll be a 5 volt difference. Red LED just doesn't get as bright as the green one, even with a lot more current going through it. So we're going to use a 220 ohm resistor to protect the red LED. And here we are on the board. Really quick demonstration. 1000 ohm resistor, 1 kilo ohm, you can see to the positive supply, and then it comes to the top lead of the LED there. So that's got to be the long lead, the anode, short lead, the cathode to that jumper. And the red LED, we got the long lead, the anode, again towards the positive side of the supply, and then when it lit up, positive side over there, and the negative side, short lead, the cathode to a 220 ohm resistor. Red for 2. So in any case, let's zoom back, and I generally assume you already know how to protect LEDs with the resistor. We're going to turn the output of the power supply on. So right now our input for the LEDs there is just floating. So they're both lit and they have the same amount of current going through them, which is much less than 1 milliamp. And you can see blue LED still really bright. The red LED barely lit up. They have the same amount of current going through them. Now we will go back. Let's do the red LED first. We will go to the positive supply rail right there. So this is like a high input from an integrated circuit or whatnot, but it probably won't get 5 volts. You'll probably have a bit less current right there. But in any case, there you can see we have somewhere around about 13 milliamps of current going through the LED and protective resistor. Let's set it low, so now we're back to floating. Floating means an input is not connected to anything. It picks up stray signals, but that's not the problem in this case. In this case, we did have a path for current to go through with nothing interrupting it. So there you can see blue LED. It's still brighter than the red LED, not by a terrible amount at the moment though, but in any case you can see we got somewhere about 2 milliamps approximately going through the blue LED. Much less current, but still really bright. So any case, that's why you'll see me make this circuit fragment, the 2 LEDs, one that lights up when the output's low, one that lights up when the output is high in circuits. So, hope you enjoyed the video. Make sure you check out one of the other ones that I'm posting. Click like, subscribe, the bell, all that. Donate to Patreon if you can, that helps out the most. I have links down in the description, but just watching videos helps out a ton. Thanks for that. I will see you in the next video.